everyone. Welcome to the west coast of beautiful British Columbia. I'm Em, and I'm an educator at the Bamfield Marine Science Centre, or BMSC for short. We are a registered Canadian charity and a not-for-profit. We're also a shared campus of the universities of British Columbia, Victoria, Simon Fraser University, University of Alberta, and University of Calgary. For almost 50 years, we've been hosting researchers from all over the world, as well as offering 4-credit university courses and running immersive public education field trips for school groups. If you like what you're seeing and you want to see more, please consider making a donation. We'll have information on how to do so linked in the video, as well as on YouTube. Just want to give a shout out to NSERC Promo Science. They provide a lot of our funding, and these shows wouldn't be possible without them. As you can tell, we're out on a beautiful boat. It's a lovely day. It's a little windy out, and we're rocking around a bit, so I'll try to keep you stable. We're going to have a lot of fun today. We've got a great big team helping us out. Let me introduce you to all of our friends and family today. So here, we've got Stacy. Stacy is our skipper. She will be driving the vessel as well as operating the dredge and all of this impressive machinery. And here we have Luke, who's our deckhand. Luke will help with the filming in a bit, and he'll be assisting Stacy in managing the dredge. Luke and Stacy are what we're calling a quarantine, which means that the two of them live together. Because of that, you may see them standing closer than 2 meters apart. Don't worry, it's all good. I will be keeping a nice broad distance from both of them. Rounding out our team, we've got Phil. Phil will be running the behind the scenes show, taking care of all the camera angles and such. And Phil's going to show you where we are located on Google Maps.
Thanks, Em. Yeah, it does look quite blustery out there today. You better hold on. So to give everyone an idea as to where Bamfield is located in the world, for many of you who haven't been here. So we are on the very west coast of Vancouver Island, of Canada, in fact. So here's North America, and then we have Vancouver Island down here, and we're on the west side of Vancouver Island, a very long, bumpy logging road to get to Alberni. And Bamfield is on these two peninsulas. The Bamfield Science Center is right on the point here. Main building, Whale Lab for field trips, Rick Center. Today I'm located at the Bamfield Volunteer Fire Department. So that's over here. And M has crossed Trevor Channel. The crew in the Alta has crossed Trevor Channel and they're over at the Wizard Islets, right in this spot right here. So just to give you an idea, it's like 2.5 kilometers from Bamfield. So thanks to the wonders of modern technology, we're bringing you a live show out on the water. Hope you enjoy it. Okay.
Thanks, Phil. So you can see that islet right here. Let me zoom in on it. That's Wizard, that island Phil was talking about. And we're on, like I said earlier, the MV Alta. So Alta actually stands for Alberta, back when the provinces used 4 letter codes instead of only 2 letter codes. So this boat was custom built for BMSC. And you can see it's actually quite similar in a lot of ways to these West Coast fishing vessels. So we're in the cabin. This is where Stacy would usually be driving from. Right now she's driving from our stern, so she can be outside with us. You can see all this high-tech equipment used for navigation. We've got some radios to chat with other boats. A nice fancy electronic chart that we can use to navigate. This is a very exciting boat to be on. We're really happy to have you joining us. Today we are doing a dredge. And last show we talked a little bit about the impacts of dredge fishing. So if any of you were watching last time for Alta Part 1, I would love to hear if you can remember some of the impacts of dredge fishing. If you're a first-time viewer, first of all, welcome. We're happy to have you here. But if you've enjoyed the rest of the show, maybe go to our YouTube channel and check out our recorded version of Alta Part 1. So if we're talking about dredging, let me just show you what a dredge looks like, jog your memory a little bit. A dredge is a metal sled with a big bag attached to it. And how that works is that we'll drag the sled along the bottom of the ocean, and anything in the path will get scooped up and will collect in this net. So last time we talked about dredge fishing, a lot of people suggested habitat destruction as one of the ways dredge fishing could impact the environment. And that's absolutely true. Today we're going to be focusing a lot on biodiversity and the importance of biodiversity and some of the threats to that biodiversity. Habitat destruction is one of the main threats to biodiversity. Dredge fishing as well can be quite destructive, both through habitat destruction, but also through the loss of lots and lots of biomass, lots of animals in the ocean. We're taking up things that we're trying to catch, like scallops, for example, or urchin. But when you dredge fish, as you can imagine, you don't really get to pick and choose what you're bringing. It looks like the dredge is coming up right now, so let me switch the camera over so you can watch it. And I'll make sure to stay out of the way. You get a lot of bycatch in dredge fishing, and that's unintended species that you're not trying to target that you get by mistake. So these are just some of the many impacts. You might be wondering, why are we doing a dredge if it's so bad? At BMSC, we really like to think that the educational value of doing these exploratory dredges outweigh the negative impacts. As well, we do use quite a small sledge, and we always dredge the same area to prevent destroying too much habitat. And finally, at the end of the show, you'll see us rowing all of the animals back along the same track where we picked them up. This is to repopulate the spot that we cleared and to make sure that all the animals get to go right back to where we pulled them up from after a nice little vacation, we'll call it, to the surface. So we're pretty excited to share with you all the fun things coming in. We've got a bunch of stuff in that net. You can see how full it is. It's pretty exciting. So we're talking about biodiversity. So let's ask you a question. I'm going to be asking lots of questions throughout the live stream. And I'd love if everyone could participate, young or old, marine biology expert or complete newbie. It's so much fun to get lots of interaction. So let me know in the comments what you think it means when I talk about biodiversity. What is biodiversity? What's a good definition of that? So it seems like maybe you folks are a little bit shy. That's okay. Maybe we'll get you on the next question. So biodiversity is a fun way of talking about all of the different animals that you can find. And not just animals. Biology refers to all living beings. You can have biology of seaweeds, biology of trees. So biodiversity is just the variety or all the different types of things that you can find that are living. So we wouldn't be talking about the diversity of rocks, for example. Today we'll be talking about the diversity of things like invertebrates, animals without spines, or algae, which are like marine plants. There's lots of different levels of biodiversity. We're going to give a bunch of different examples. But first of all, your next assignment, I want all of you to type in the comments. Please let me know either, you can decide which you want to disclose, what color your hair is. So let me know the color of your hair, or if you're feeling like sharing, let me know where your grandparents were born, which country your grandparents came from. And we'll explore a little bit one of the layers of diversity that exists, which is genetic diversity. So within our live stream, within our audience here, I'm seeing a lot of different hair colors. We've got some folks with blonde hair, some folks with brown hair. I saw someone mention gray hair, maybe one of our mature continuing education students. So lots and lots of different hair colors. That's controlled by your genetics. So that means that each person with a different hair color has a different set of genetics. That is the lowest level of biodiversity, is genetics. So we're talking about where your grandparents are from. That's going to let us know a little bit more about where all of your genes are coming from. So let's take a look at that chat. We've got Linda, whose grandparents are from England and the UK. Oh, sorry, in the Ukraine. We've got Adam, who's got grandparents from Norway and Brazil and Croatia. Saw Linnea earlier, said her grandparents are from Sweden. So we've got actually really high genetic diversity in our population. That's pretty cool. Let's take a look at the species diversity in our table. To do that, I'm going to hand off this camera to Luke, who will be taking over the filming. So we're going to put down the camera on this table here, give you a snail's eye view for a moment, and then we're going to zoom around and do a swap. So now Luke's picking you up and he's going to walk around the back of the boat and we'll get ourselves all oriented. So there Luke goes. Hi, Luke. So let's take a look at all of our species diversity. Look at all these different things. We can pan across the table. So many different organisms. Is anyone watching the live stream with their pets? If you are, let me know what kind of pet you're watching with. But unless you were watching the live stream with your dog or your cat or maybe your parakeet, it's likely, someone said dog, awesome. It's likely that the species diversity of our audience is actually pretty low. That's okay, we've got a whole bunch of humans watching. If you're an alien, maybe let me know and we can have a bit of a higher species diversity. That'd be kind of fun. But compared to this table, we've got nothing. You can see all the different sea stars that we've got. We've got a whole tank full of sea cucumbers, which is super exciting. And we've got a ton of what are called sea squirts. These squishy little orange things are all sea squirts. And there's a couple worms over here as well. So very high species diversity. And that's pretty common for Bamfield and for this region in general. We've got a really high species diversity on the coast, partly because there's tons and tons of nutrients in this water. We have a really rich environment, lots of kelp, lots of stuff in the water, which makes tons and tons and tons of food. So really high species diversity. So we've got the lowest level, genetic diversity, and then we move up to species diversity. The highest level of diversity, the highest organization is ecosystem diversity. And in BC, we've got one of the highest diversities of ecosystems in the world. We've got the mountains and the deserts and the ocean and forests and all kinds of different forests and lots of different seafloor environments. So really, really diverse province. As far as the ecosystem diversity in this table goes, we're looking at really quite a sandy bottom. So only really one kind of ecosystem. But it's neat because if we think about Wizard, we are currently on the rocky bottom side of Wizard Islet, which means that even just on Wizard, we've almost got two different ecosystems, which is so incredible to have that much diversity just on one or the other side of such a small region. So lots and lots of biodiversity. Linda wants to know why there's so many sea cucumbers. Maybe it's because we got really lucky and all of my hopes and dreams came true. I love sea cucumbers, and in areas like these, you often get big groups of sea cucumbers all hanging out together on the bottom of the seafloor. So lots and lots of lovely sea cucumbers. They love eating all of the dead matter and all of the little particles in the sand. And so you'll often find them in habitats like these. Like I said earlier, though, in a dredge, you don't get to pick what you find, and so we just got lucky and got a bunch of sea cucumbers. Pretty happy about it. Hopefully, I explained a little bit about what biodiversity is, but let's get into quickly why it's important, right after a comment from Luke. Someone wants to know what the collective noun of sea cucumbers is. I would love to know what the collective noun of sea cucumbers is. Someone's gonna have to Google it. I don't know what the groups of them are called. Clubs of cucumbers, maybe? I'm not sure. Great question. So let's go back to biodiversity and thinking about why it's important. I would love to hear from you as to some of your guesses as to why biodiversity might be really important. It's interesting in conservation ecology, the ecology of conserving and protecting biodiversity, everyone's kind of come to this conclusion that it's really important to protect, but it's always important to remember why that actually is. We can't just say it's a good for the sake of it being good. Rowan says that biodiversity is good for ecosystem stability and resilience. That sounds like it was taken out of a textbook. I think we've got a biodiversity expert at home. That is totally correct. Ecosystem stability means that when there's a big disturbance, something really bad happens, that ecosystem can bounce back. It can recover. And you're totally correct. Having lots of different species around means that if they're knocked askew by a disruptive disturbance, those species that are there can help recover. And that's a really good lead into our next little segment. A pickle of sea cucumbers. Yes, that sounds like a joke, but I'm into it. Thank you. Sounds like a dad joke, maybe. Oh, that was Linnea. Thank you, Linnea, for that dad joke. Last time we did our Alta show, we talked a lot about sea star wasting disease, so I won't get into it too much here. But again, if you want to learn more, check out Alta Part 1 on YouTube. So quickly, sea star wasting disease was an epidemic in 2013 that killed a lot of sea stars, particularly sunflower stars. So we're talking about disturbances hurting biodiversity. This was a major disturbance that really hurt a lot of species of sea stars. But as far as resilience of the system goes, because the system had so many different types of sea star, it meant that while some, like the sunflower star, were really negatively affected, there were lots of other species around that could kind of move in and help fill that gap. So sunflower stars could get up to this big. So for example, this leather star, which is quite a bit smaller, isn't really completely doing the exact same thing. This leather star was actually quite minimally affected by sea star wasting disease. It still got sick, some individuals died, but overall it was less impacted than the sunflower star. And so in comparison, you can see that having lots and lots of species of sea star around means that when some of them die off, you've got other ones that can kind of step in and help them out. Someone wanted to know what these leather stars smell like, and it's a fun fact that if you rub a leather star, it's almost like a scratch and sniff sticker, but if you rub the leather star and then smell it, it smells a bit like garlic. They're a little stinky. So I hope no one's hungry at home thinking about garlic. But this is one of the beauties of doing these kind of shows where you are in your living room. So if you're hungry, you can just get up and get a snack. So leather stars do smell like garlic, and I'm sure that helps make them smelly to things in the ocean. Awesome. Oh, Stacy has just said that some people think that leather stars smell like gunpowder. That's really interesting. I don't think that I've ever smelled gunpowder, so I wouldn't even know if it did. That's awesome. Are there any more questions or comments from our viewers? Also, shout out to those of you on Zoom, but we've also got a whole bunch of you on YouTube. Phil, are there any comments or questions coming through YouTube? Nope, sounds like YouTube is all set. That's awesome.
Oh, hey, Em. I just unmuted myself there.
Oh, here's Phil. Sorry, he was all mute. Here he comes.
I think it's in regard to sea cucumbers. How deep do they live?
How deep do sea cucumbers live? That's a great question. I've seen them when I'm diving up to 20 meters deep, but I'm sure they can go deeper than that. These sea cucumbers that we have here are a species called the California sea cucumber, which is just one of the many species we've got in this ecosystem. We've got a bunch of sea cucumbers that are filter feeders, meaning that they sit on the bottom of the ocean and filter out water coming by them. These ones are deposit feeders, meaning that they eat the food kind of out of the sediment. So there's lots of different sea cucumbers. Oh, how long can sea cucumbers live for? That is a great question, and I don't even know the answer to that. But maybe Phil can do a quick Google search. Maybe he can get back to you on that one. That's a great question, though. How long do these things live? Those are really important questions when we're thinking about conserving biodiversity, because when we're managing species like sea cucumber, this may not look super appetizing to some of you at home, but sea cucumbers are a fished species. In this area, divers will go down and harvest them, and they're really tasty apparently. I've never eaten one, but they're a huge export to countries in Asia where they're eaten as bêche de mer, which is a very high delicacy. But when you're thinking about how to conserve species like sea cucumbers and how to preserve biodiversity, you need to know a lot of things about the life histories of these animals. So life histories can refer to anything from how many babies they have to how often they're reproducing, how long they live, how long they're growing. And with things like rockfish, for example, which you can see we didn't get any of in our dredge because they're swimming animals, they would probably swim out of the way. But with things like rockfish, it takes these fish a really, really long time to grow up, and it takes them almost into their teen years before they're sexually reproductive. So really slowly maturing species. So as we're harvesting things like rockfish, it takes them a really long time to recover. And so that's important to consider when you're thinking about conservation. We're just getting hit by a bit of swell right here. You can see all the water sloshing around. Our sea cucumbers are flying around a little bit.
Hey,
Woo!
what I could
Yeah,
find
feels
about
bad.
sea cucumbers, they live to around 5 to 10 years.
Sea cucumbers live between 5 and 10 years. That is incredible. Good for them. So these ones will be kicking around for much longer. Let's take a look at some of the species we've got on our table. Here, we've got a treat for you. This is a moon snail. We talked about moon snails in our first lab. These are the animals that are drilling holes in our shells. They are ferocious hunters and they roam all over the seafloor looking for prey. Just looking through our table right here trying to find a shell that's got a hole in it. Here's one. You can see that little hole right there was drilled by this moon snail. Ooh, and Stacy has found what she's calling a not quite hole. So it looks like the predation attempt was given up. Moon snail. How do they do it? Someone wants to know how moon snails drill these holes. It's a great question. Mollusks, like moon snails, have a lot of them what's called a radula. It's like a tongue covered in spines, and lots of them will use it to just rasp away at algae. A lot of them are herbivores. They eat plants. Moon snails have adapted this radula to make sort of a drill. So you can see that perfect hole, and so they drill into the shells using a combination of their radula and also acid. Great question. How big can moon snails get? This is probably pretty close to the max size that I've seen them, but it's pretty hefty. They've all got what's called a fleshy foot, which is hidden inside their body. And that foot can be up to 2 times as big as their body. So it's this giant, massive, fleshy foot. And then when they're threatened, like being pulled up in a dredge, for example, they pull that foot back in and they cover the opening with what's called an operculum to keep all the bad stuff out, to keep all the nice water in.
Hey, I have a question from the YouTube world.
Question from YouTube, Phil. Yeah, go ahead.
Ali Miller wants to know, why are they called moon snails? Do you have an idea, Em?
Ali Miller wants to know why they're called moon snails. That's a great question. You guys are really stumping me today. I don't know why they're called moon snails. Do you know, Phil?
I can only assume from their large round size. I don't think they've been found on the moon just yet.
Because they're nice and round and they block out the sun if you're an innocent little clam. Cool. So I found earlier a little hermit crab. We've got a nice little crab right here. Crabs are an interesting group of animals. They have what's called an exoskeleton, which helps protect them nice and hard. We've got this little crab leg from what was likely a crab molt. So for crabs to grow, they have to take off that exoskeleton and grow their soft, squishy bodies within. But crabs are fun because when we're thinking about threats to biodiversity, such as climate change, one of the threats that isn't just the ocean changing temperature is kind of the other impact of climate change, which is ocean acidification. So when we're thinking about greenhouse gases like carbon dioxide, which we're releasing through the burning of fossil fuels, that carbon dioxide doesn't just mess with our climate, it also dissolves into the ocean and it forms a sort of acid. And so things like these clams have a really hard calcium carbonate skeleton or exoskeleton, in this case a shell, and that calcium carbonate is being dissolved by that acid that's produced by ocean acidification, or the dissolving of carbon dioxide into the water. However, things like crabs have a different composition of their exoskeletons. They're not made of the same calcium carbonate. And so largely crustaceans like shrimp and lobsters and crabs have been found to have fewer effects of ocean acidification. So that's great for crabs like these. But it's not so great for things like clams or corals, for example, that have really hard shells that they need lots and lots of calcium carbonate. So I know I'm talking about corals and we're not in a tropical reef system. I wish we were in the Bahamas, that'd be excellent. But we've actually got corals in our very own backyard too. We've got these little tiny things called cup corals, and they're about that big, and they're super small and orange. You can see Stacy looking somewhat frantically for one on the table as I've started talking about it without having one in my hand. Maybe we'll find one in a bit. We do have corals here as well. Does anyone want to suggest any other threats to biodiversity? So we've talked about ocean acidification. We've briefly touched on climate change. We mentioned overfishing a little bit. Are there any other threats that you can think of? Anything nefarious that could be threatening the beloved biodiversity of our ecosystems? Chaz Francis says invasive species. Yes, absolutely correct. Yes, invasive species. Anyone who knows me knows that I love talking about invasive species. We've got a lot in our backyard. It's very sad. For example, we've got this species of tunicate, which is a sea squirt, and they're orange and they're slippery and they look very innocent, but they can be super invasive. Lots of benthic communities fight really intensely for space, and animals that are able to overgrow others often win these battles. So these tunicates, these sea squirts, are forcing out natural native animals and overgrowing them at quite an alarming rate. Yeah, invasive species are a great suggestion. Someone's suggesting water pollution. Yeah, absolutely. So there's lots of forms that water pollution can take. I have to admit to you, a lot of the houses in Bamfield are quite old, and so they don't run into septic systems. They don't go into a waste processing system. They just go straight into the inlet. And so that's one example of water pollution. It's also why we don't go swimming in Bamfield inlets, because of all of the feces and such floating around, fun things like that. Oil and gas are also a major source of pollution. Those of you on the West Coast, I'm sure, are keeping really up to date on all of the debates around the pipelines. But that's one of the big concerns in BC, that something's going to happen and we're going to get oil and gas polluting our beautiful, somewhat pristine natural environment out here. Of course, besides the feces that I just mentioned. Other sources of pollution are things like microplastics. When we did our plankton part 1 lab, we investigated some of the impacts of little tiny fragments of plastic that float around in the ocean and can actually travel all the way up the food chain from plankton up to us. So those are affecting things like seabirds. I'm sure that you can't hear it because this microphone is so good at canceling out other noise, but on Wizard, we've got colonies of oyster catchers, which are an incredible bird. I'm not sure if you can see them flying around. They're black birds with orange noses that look like carrots in the nose of a like a carrot in a snowman. Sorry for that stumble there, folks. So we've got these birds like oyster catchers that are flying all over the place, feeding their babies, and sometimes they feed their babies things like plastic. It's pretty sad. So seabirds are globally declining, and that's absolutely a threat to biodiversity that's caused by a kind of pollution, plastic. Any more suggestions for threats to biodiversity? You got a lot of them. That's actually quite almost all of them. We've got our fishing, habitat destruction, and things like dredges. Another form of habitat destruction can be seen in building construction. So if any of you like going down to the beach, nice, beautiful sandy beach, maybe there's some restaurants on the boardwalk, that beach probably looked a lot different before humans came along and made it a lovely destination. So that's one way that we're destroying habitat. When we're looking at all these creatures that are on the bottom that are getting dredged up, we've got lots of sea squirts, we've got all these worms. These are bent straw worms. And in our first show, we talked a lot about how gray whales actually eat these worms. But there's also quite complex structures under the water here. And we can get a brief look at them by looking at something simple like a rock here. So you can see a simple rock. This is what we call a live rock because it's covered in this pink crusting algae. We've got a bunch of barnacles on it. We've also got, looks like a bryozoan. Bryozoans are these incredible animals. They're lacy animals, and they form immense colonies. And I was just doing a bunch of reading on nutrient cycling last night, and I said earlier in the show that we live in an incredibly nutrient-rich area. That's because of what's called upwelling. I won't get into it too much because I'll get sidetracked. But upwelling in the winter brings lots and lots of nutrients into our waters for kelp growth and phytoplankton growth, lots of food. But in the summertime, there's less upwelling, and so nutrients start to deplete a little bit, which is a hard problem because summer and spring are really the big growing season for things like kelp. So how do our kelps and phytoplankton get around this problem when there's less upwelling? And it's from things like bryozoans, because bryozoans live all over kelp and they pee on the kelp. And when they pee on kelp, they release all sorts of nutrients like ammonia that are a really important nutrient for kelp growth. It's a good source of nitrogen. And so folks are finding that bryozoan pee is a really important source of nutrients in the summertime for kelp. So if we're doing a dredge and we're bringing up all this stuff, you know, this really sensitive habitat, like these live rocks that are covered in so many different types of animals, can really get super hurt. So habitat destruction is huge. That's awesome. So maybe if you folks have any other general questions, now would be a great time to comment those or let me know any things that you've been thinking of, or maybe just let me know your favorite animal that you saw today. I'd love to hear of it from you. We can also, while you're thinking, head over to Wizard, get a little closer, because I can see some seals laying on the rocks. And it would be amazing to get a look at some of the more charismatic individuals in this area. Sea slugs. Sea slugs are always a crowd favorite. I haven't seen any in the dredge, unfortunately, but I'll keep looking and I'll let you know. Stacy said that we call seals beach slugs. So we don't have sea slugs, we've got some beach slugs instead. So we talked a lot about the biodiversity of lots of these invertebrates or animals without spines. And we talked a little bit about fish. We haven't talked about everyone's favorite, the whales. Whales and seals and sea lions and all those amazing things. So we've got a really great diversity of whales in this region. And actually, this weekend, over May Long weekend, a dead whale was found. It was covered in bite marks and rake marks, and its tongue had been eaten out, its belly was slit open, and its liver had been consumed. Does anyone want to guess what kind of animal would do such a thing to a whale? Who would rip open the stomach of an innocent humpback and eat its tongue? What kind of creature could be capable of such horrors? Let me know in the comments. These whales also eat seals. So there's a hint for you. The thing that ate the whale was another kind of whale. In fact, it's actually a kind of dolphin. Any guesses? They're black and white and particularly beautiful and well renowned on the West Coast. Someone guessed killer whales. Absolutely correct. So we've got a bunch of different whales in this coast. We've got our humpbacks, like the dead whale found. We've also got killer whales. Even within the species killer whale, we've got 3 ecotypes. So there's even diversity within a species. So the ecotype, or the type of killer whale that would have eaten the humpback, was what's called a transient or big orca. These whales hunt things like seals and sea lions. And if any of you are following along our social media, we posted a video a couple weeks ago of these killer whales actually coming into Bamfield Inlet. And one of the fishermen on the dock, my next door neighbor, says that he watched them kill a sea lion. They're pretty ferocious. They're not doing it to be mean, and they're not doing it for sport. They're doing it to feed themselves, just like any of us. One of the other ecotypes of killer whale are the resident whales. These whales eat salmon, and in particular, the southern resident killer whales in this area are eating Chinook. The third type eats something that's not fish, that's not marine mammals, but a third thing. That third thing is sharks. These are our offshore killer whales, and they've been found washed up on beaches with their teeth sanded down as if they'd been rubbing their teeth on sandpaper. And this is because shark skin is super rough, and so after a lifetime of eating sharks, their teeth get sanded down. So, if we don't have any more questions, maybe it's time for us to say goodbye. Maybe I'll just throw it over to Phil one last time, see if there's any questions on our YouTube channel. Any questions on Zoom?
Hey there. No, just people mentioning about orca, possibly ones that have taken down that whale. And yeah, everyone's enjoying the show quite a bit.
Wonderful. Well, thank you so much for participating. It was really fun spending time with all of you today. We really enjoyed our time out here on this crazy wavy journey, and I hope you had fun as well. This, of course, wouldn't be possible without the rest of the team. So let's say thank you, a big thank you to Stacy for driving our boat, to Luke for filming and deckhanding. Thanks to Phil for helping manage the comments and questions. And thanks to NSERC Promo Science and all of our donors for helping support us financially. And again, if you want to help out Bamfield Marine Science Center, please consider making a donation. It's been really fun, but it is time to return all of these lovely animals to the ocean. So we're going to start putting them back exactly where they found them. And with that, I'll say goodbye to you and goodbye to all the animals.
Bye, everyone.